Ladies and gentlemen of Algebra 2, welcome to Unit 5. This is Unit 5, Video 1, talking about the fundamental counting principle. This entire unit is going to be a lot of probability. And so we got to start looking at, basically we're trying to figure out how many ways something can happen. So we're trying to figure out all the different possible scenarios for a given event. So that's kind of what we're looking at, is what are the independent and dependent events, what's the difference there, and then how do I count possible things are happening. So, number of possible license plates for a state is too great to count by listing all the possibilities. I mean, you could go, you know, A, 0, 0, 0, A, 0, 0, 1, but your hand would fall off long before you ever reach the end. So it's way more efficient to count the number of possibilities by using what we call the FCP, or Fundamental Counting Principle. And the fundamental counting principle says multiply every single way that each individual event can happen. So if we look at this, what we're looking at is how many different things can go in the first, second, third, how many different things can go in the first, second, third spot. So there can be 26 letters in the first spot, 26 letters in the second spot, 26 letters in the third spot, and then 10 digits, 10 digits, 10 digits. And it's 10 digits because I'm counting 0 through 9. All right, 0 can easily go in there. So what I'm doing is multiplying 26 multiplied by itself 3 times. Then I'm going to multiply that times 10 times 10 times 10. And my answer ends up being 1757600. So 17 million different possible combinations for license plates, just going by all the letters, all the numbers. That doesn't include like vanity plates or any specialized plates or anything like that. So terms to be familiar with: outcome is what happens after I do something. What was the outcome? Sample space is everything that could possibly happen. All right, if I flip a coin, I get 2 options, heads or tails. That would be the sample space. Sample space of drawing a card would be all 52 cards. All right, an event is, you know, doing something, flipping a coin, rolling a die. That's kind of what I'm looking at. Independent events are events that have no effect on each other. Okay, independent means I am independent, means I don't need anything else or anybody else to tell me what to do. So letters and digits on a license plate would be considered independent. So dependent events means one changes the next. So if I got 2 events happening in succession, meaning one right after the other, that means one is going to affect the other. So I would definitely pause, write all these down, make a note, put big stars by it, you know, put something in there to remind you that you have some terminology that you have to be familiar with. All right, so let's look. A sandwich card offers a customer a hamburger, chicken, or fish in either a plain or sesame seed bun. How many different combinations of a meat and bun are possible? So, first off, these events are going to be independent because it doesn't matter if I get a hamburger, chicken, or fish. I can still get a plain or sesame bun on all of those. So my choices are to do it by tree diagram or by fundamental counting principle. Tree diagram, you're going to figure out takes a longer time because you've got a hamburger, chicken, fish, then you've got sesame seed or plain, sesame seed or plain, sesame seed or plain. So all that is 3 times 2, which is going to be 6 different combinations of sandwiches. And that's what I got here. 1, 2, 3, 4, 5, 6. So the fundamental counting principle in words and in actual type is going to be right here. So you're going to be, if an event can occur in m ways, another in n ways, then the number of possible events is going to be m times n. So that's kind of like looking at what we had here. If you can have 3 different types of sandwich on 2 different buns, 3 times 2 is going to give you 6. So to check a voicemail, owners may enter a 3-digit code, determine whether choosing each number is independent or dependent, then determine how many codes are possible. So, independent or dependent, well, I can repeat. I mean, my 3-digit code could be 000, I could be 111. It doesn't matter what it is. Each individual number that has no effect on the other ones. So this is going to be independent. So again, I look at how many different choices I can have. Well, 10 digits, 0 to 9, 0 to 9, 0 to 9, times 10 times 10. So I've got 1,000 different variations I can go through. That's what it's going to be there. Now, Carly wants to take 6 different classes next year, assuming that each class is offered each period. How many different schedules could she have? Now, this one is going to be dependent, and I'll tell you why. Because depending on which class is where is going to determine what her schedule looks like. And kind of here's another way to say that. You have 6 different classes next year. You know, if you're taking chemistry first hour, you're not going to sign up for chemistry 5th hour too. Okay, that doesn't make sense. You're not going to take chemistry 2 hours of the day. So it's dependent because the next event, you know, the first event affects the second event. So say you sign up for chemistry first hour, then you sign up for math second hour, then you sign up for English third hour, and then you sign up for, you know, gym fourth hour, and so on. Well, if I signed up for chemistry here, I'm not going to sign up for chemistry later. If I sign up for math here, I'm not going to sign up for math later. So my different options, so it's going to be dependent. It's going to look like this. I got 6 choices for the first hour. That leaves 5 for second hour, 4 for third, 3 for fourth, 2 for fifth, and 1 for sixth. So it's basically going to be 6 times 5 times 4 times 3 times 2 times 1, also known as 6 factorial. And that's what that little exclamation point means. That means multiply down to 1. So that means I got 720 different possible combinations for my classes here. So a garage door opener has a 10-digit keypad, and the code to open the door is a 4-digit code. So now I can have any 4-digit code I want. So I can 1 1 1 1, or 1 2 3 4 for those of you guys who lack real imagination. One does not affect the other. Okay, so this is going to be independent. I can repeat. I can do whatever I want. I can put whatever letters I want. So for 4 digits, 10 choices, 10 choices, 10 choices, 10 choices. So 10 raised to the 4th power, which is going to be 10,000 possible combinations. All right, notice 4 digits. How many spots, how many options do I have for each part? So each player in a board game uses one of 6 different pieces. If 4 players play the game, how many different ways could their players choose the game pieces? All right, this one's going to be dependent. Okay, so if we're talking about these Monopoly pieces, if the first person takes the car, well, then the car is no longer on the board. The second person takes the dog, well, then you can no longer have the dog. If the third one takes the ship, then the ship's no longer on the board. So you got 4 players playing the game. 1, 2, 3, 4. There's 6 pieces. That first player's got 6 different choices. That means once he takes one off the board, there's 5 left, then 4, then 3. So that's going to be 6 times 5 times 4 times 3. So 30 times 4 is 120, times 3 is going to be 360 different ways you can do that. All right, so basically I'm looking at how am I multiplying my different options. All right, so take a look at this, play around with this a little bit. If you have a calculator, I can show you how to make that do most of the multiplication work and make your life easier. Come talk to me with questions, and let's kick off this unit right.